Finding the LCD, the least common denominator. To add or subtract fractions, they must speak the same language. In other words, they must have what? A common denominator. To help you find the LCD of a rational expression, we're going to follow a few steps. The first step is to number 1, factor each denominator separately. 2, organize using the chart. 3, the LCD is the product of all unique factors or columns. Example 1. Find the least common denominator for problem A. We have the fraction y plus 5 all over y squared plus 2y minus 3 and the fraction y plus 4 all over y squared minus 3y plus 2. Here's the reminder of the steps that we are going to follow. Step 1 is to factor each denominator separately. So on the side of our paper, we're going to look at the first denominator. We're going to use the AC method and expand it. Do factor by grouping, and we find that it factors into y minus 1 and y plus 3. Now that we have factored the first denominator, we need to factor the other denominator. Again, because it's a quadratic, we are going to do the AC method, so we expand it, do factor by grouping, and notice it factors into y minus 1 times y minus 2. So all of that was step number 1. Now we're ready for step 2, which is to organize using the chart. Well, what exactly is this chart? The chart is made up of your original denominators and the LCD at the bottom. The chart is simply an organizational tool made up of rows and columns. Looking at your first denominator, we have y squared plus 2y minus 3. The columns represent the factors that make that up. Well, on the side of our paper, we saw that it factored into y minus 1 and y plus 3. Those are two separate factors, meaning we are going to use two separate columns. One column is for y minus 1, another column is for y plus 3. Now, once you have placed the factors in the columns, those columns only represent those values. So when we look at our second denominator, we know that it is made up of y minus 1 and y minus 2. But we have to organize them accordingly. Well, y minus 1 is the same thing. There's already a column made up of y minus 1s, so we put them in the same column. But y minus 2 cannot go in the middle column because it's not the same as y plus 3. So therefore, y minus 2 gets its very own column. All we've done is sorted the factors. That was step 2. Step 3 is the LCD is the product of all unique factors or columns. We'll look at your first column. What does that represent? Y minus 1s. What does your middle column represent? Y plus 3s. And your last column represents y minus 2. So your LCD is y minus 1, y plus 3, and y minus 2. Example B, again we're being asked to find the LCD for the fraction 7x squared over x minus 4 quantity squared and the fraction 5x over 3x minus 12. Again, our three steps are listed on the side of our paper. So our first step is to factor each denominator separately. On the side of our paper we have x minus 4 quantity squared. But remember, an exponent of 2 means it's that value times itself twice. So in other words, that really means x minus 4 times x minus 4. And it cannot factor anymore. Now we look at the other denominator of 3x minus 12. We want to see, and they notice they do have something in common. They both have a 3, so we factor out a 3, which gives us 3 times x minus 4. And that is done factoring. So now that we've factored the denominator separately, we're ready for the chart, which again is just made up of rows and columns. And now we want to list the factors. The first denominator of x minus 4 squared is really made up of x minus 4 and x minus 4. Now 3x minus 12 is made up of an x minus 4, but it's also made up of a 3. A 3 must have its very own column. Now that we have sorted the factors, we're ready to identify the LCD. The first column represents x minus 4, the middle column represents x minus 4, and the last column represents a 3. So your LCD is 3 times x minus 4 and x minus 4. We prefer to have the 3 at the front so that it looks like a distributive property. Example C. Identify the LCD for the fraction 7 over x minus 5 and x plus 3 all over x squared minus 6x plus 5. There's your 3 steps, but this is going to be your try it problem. Let's see how you did. On the side, you should have factored your denominator. Your first denominator, x minus 5, cannot factor, but the second denominator, once expanded and you factored it, you should have noticed it is made up of x minus 1 and x minus 5. In the chart for your first denominator of x minus 5, since it does not factor, x minus 5 is the one and only factor. Your second denominator is made up of x minus 5 along with x minus 1. So your first column represents x minus 5, your second column is x minus 1, so therefore your LCD should be x minus 5 times x minus 1. Now we're going to look at writing equivalent rational expressions. We must use a translator, in other words, to multiply by a value of 1 so that the fractions can speak the same language. If we look back at example 1a, our original fraction was y plus 5 all over y squared plus 2y minus 3. And we know that the denominator factored into a y plus 3 and a y minus 1. Now back in problem 1a, we were asked to find the common denominator, or the LCD. We noticed the LCD was made up of y plus 3, y minus 1, and y minus 2. Well, our current fraction needs to have a translator so that it can speak the same language as the common denominator. In other words, look at the denominator and what piece is missing. And if you notice, the translator, the piece it's missing, is y minus 2. In order for us to maintain the value, you have to multiply by 1, which means what you multiply in the top, you must also multiply in the bottom. So in the bottom, we now have the current common denominator, but in the top, we have the binomial y plus 5 times y minus 2. And when you multiply those two, you will find y squared minus 2y plus 5y minus 10. So I did multiply the two top binomials. Once multiplied, we want to combine any like terms, and notice the two terms in the middle do simplify, and so your new equivalent fraction is y squared plus 3y minus 10 all over y plus 3 times y minus 1 times y minus 2. Those two fractions are the same thing, they just look different. Now also in example 1a, the other fraction was y plus 4 all over y squared minus 3y plus 2. We had also factored the denominator and saw it was made up of y minus 2 and y minus 1. Again, we know the LCD was y plus 3, y minus 1, and y minus 2. What needs to be the translator? Well, the piece it's missing is the y plus 3. So we need to multiply the top and the bottom by y plus 3 so that it maintains its value. In the top, we have a binomial of y plus 4 times y minus 3. And if you multiply those two, you will find y squared plus 3y plus 4y plus 12. Now that we've multiplied, we're now ready to combine any like terms. And if you notice in the middle, those two terms do combine to give you y squared plus 7y plus 12 all over that common denominator. And again, these are equivalent fractions. They maintain the same value, they just look different. Now the two fractions at the bottom are speaking the same language because they have the same denominator. Example 1b, we were given the fraction 7x squared all over x minus 4 quantity squared. If we factored the denominator, we know that's really made up of x minus 4 and x minus 4. But looking back at the problem, we found the common denominator to be 3 times x minus 4 and x minus 4. What needs to be the translator so that this fraction can speak the same language? Well, the translator, or the piece that it's missing, is the 3. So we need to multiply the top and the bottom both by 3. Well, that means in the top we now have 7x squared times 3, which we know gives us 21x squared all over 3 times x minus 4 times x minus 4. These are equivalent fractions, meaning they're the same thing, they just look different. Now the other fraction in example 1b was 5x all over 3x minus 12. Again, we had already factored the denominator and knew that that was made up of 3 and an x minus 4. But we found the LCD, or the common denominator, was actually 3 times x minus 4 and x minus 4. What needs to be the translator to help this fraction speak the new language? And the translator will be x minus 4 over x minus 4. And so in the numerator you have 5x times x minus 4, which means we can distribute that 5x to become 5x squared minus 20x all over 3 times x minus 4 times x minus 4. And again, these are equivalent fractions. They're the same value, they're just now this looks a little different. Now the two fractions we have at the bottom are now speaking the same language, meaning we could, if we wanted to, add or subtract these two fractions. Example 1c, we were given the fraction 7 over x minus 5. And the other fraction was x plus 3 all over x squared minus 6x plus 5. This is your try it problem. Rewrite both of these fractions with the new common denominator. Let's see how you did. For the first fraction, we saw that it could not factor, but the common denominator was x minus 5 and x minus 1. So in this case, the translator would have been x minus 1 over x minus 1. In the top, the numerator, you would have 7 times x minus 1, which when you distribute gives you 7x minus 7 all over the common denominator. Again, those are now equivalent fractions. For the second fraction, we rewrite it in factored form to see what we really have. And we rewrite it with the common denominator to see if it's speaking the same language. In this case, notice this fraction already is speaking the same language, so your translator would just be a 1 or a 1 over 1. 1 times x plus 3 will still give you x plus 3 all over x minus 5 times x minus 1. And again, these are equivalent fractions.